All right, let's talk about pictographs. Let me get this out of the way. And this. Okay, here we go. So pictographs, this is nothing new, guys. This is something you guys have done since kindergarten. We may do a little more advanced stuff today than what you have before, but this is mostly going to be a review. So I'm going to try to go pretty quickly. So a pictograph is a type of graph where the data is represented by a picture or a symbol. In kindergarten and first grade when you did graphs, most of the time one picture equaled one thing. Okay, now as you've gotten older in second and now third grade, you guys are seeing different examples where each balloon equals 10 balloon animals. So this picture of a one balloon doesn't just mean one balloon, it means 10. So you have to count them by tens. So for example, 10, 20, 30, 40 cats were made. 40 balloon cats, okay? Now, what is this saying? What does half a balloon mean? Okay, so you notice like at the end of the dogs and the end of the pigs, there's a half balloon. How many do you think that's going to be? Yeah, 5, because half of 10 is 5, right? And so pigs would have 10, 25. So sometimes they'll do that where a half symbol will mean half. They won't usually go smaller than half because it gets a little hard to tell. But that's something you might see. Okay. All right, so let's fill out our chart based on what we see on the pictograph. So we're going to take information from the pictograph and put it on a frequency table. Okay, a lot of what these lessons are just moving data from one format to another. Okay, so how many did we say were made that were cats? 40, because there are 4 balloons and each balloon represents 10. Okay, dogs, 10, 20, 30, 40, 55. 55. Okay. Horse, we have 30 because there's 3 balloons and each one represents 10. And like we said before, pigs have 25 because of that half balloon. Okay. Me, so I can see. All right, here's our little snapshot of the math page from the book. Okay, they've got a chart or a frequency table on the right. We're going to use it to record the places the third grade classes would like to go during a field trip. How can you show that data in a pictograph? Okay, so first off, they want to give us a title. Okay, so let's see. What should our title be? I think it should be the same as our frequency table, right? Field trip choices. So I'm going to move that up so it's nicer. Okay, and so some of them chose museum. So they've given us one here, so they're showing us where to put the data. So the places are going to go on this side just like they are on the frequency table. All right, so Science Center is going to go right here. I'm not going to bother changing the size. You can still see. Aquarium here and zoo down here. Okay, now it says choose a picture for the key and let each picture represent 4 students. And so if you were doing this at home, you might choose to draw a certain shape and each shape equals a certain number of students. Or you might choose to draw a bus, a school bus, because you go on a school bus to go on a field trip. So sometimes it's nice to let your picture kind of match the theme of the data that you're doing. So what you want to do is, I'm just going to use circles because that's the easiest for me to do from my laptop on the chart here. But here's what we have to decide. We have to decide our key. Okay, so take a look at the numbers represented here. We've got an 8, a 20, a 14, and a 12. Do you think counting by 5s is going to be helpful here? Oh, counting by 5s would be tricky with 8 and with 14 and 12. 10s? No, that would only work for Science Center, right? What about 2s? Would 2s work for every 2? I think we could do 2. You could also do 4s because all of them have 4s, but that might be a little bit more complicated. I think if I were doing this, I would say each circle equals 2 students. Okay. So, to put that into practice, how many chose the museum? 4. So to get to 4 counting by 2s, we go 2, 4, 6, 8. Sorry, I dropped my finger. So we do 4 dots. 2, 4, 6, 8. Okay, now I know I'm saying dots, and that might make you think of the dot plot that we did in the other lesson. I just chose dots as my shape. If you were doing this, like I said, you might choose a different shape. I'm only doing dots just because that's easy to draw, so you don't have to do dots. I don't want you to confuse that with the dot plot. Okay, Science Center, 20 chose that. So I might have to put these a little closer. I'm going to overlap them a bit. 4, 6, 8, 10, halfway there, 12, 14, 16, 18, 20. So I should have 10 dots there because each dot equals 2. So 10 times 2 is 20. Okay, aquarium, we had 14 people choose that. So 2, 4, 6, 8, 10, 12, 14. That should be 7 dots. For the zoo, 12 kids chose that. So 2, 4, 6, 8, 10, 12. Okay? You see how that works? That's a pictograph. And again here, I'm not going to do this one for you because I think we can figure this out. So let's just talk about it. I'm not going to actually type it in. Look at the data that's represented on the pictograph. All right. First thing you want to look at is your key. All right. Each star here equals 5 animals. So we're going to count these by 5s. 5, 10, 15 cows. So you would write 15 here. 10 horses. Ooh, there's a lot of chickens. 5, 10, 15, 20, 25, 30, 35, 40, 45 chickens. My goodness, that's a lot of eggs. 5, 10, 15, 25, 30. Hang on. 5, 15, 25, 35. Yeah, sorry. 45 chickens, 35 ducks. That's a lot of birds, y'all. Okay, so do you see how that works? The most important piece here is that key. The key is the key, all right? Because otherwise that totally changes your information. If you thought that each star equaled 10, that would give you a very different set of data. If you thought that each star equaled 1 cow and 1 chicken, again, a very, very different set of data. So the key matters. All right, Jenny pulled marbles from a bag one at a time, recorded their color, and put them back in a bag. It's kind of like what we did with our frequency table the other day that you guys did at home on the Google slide. So they've got the marble experiment data here. It's here in the frequency table, and they have given us a key. It says right here, use this key. So first things first, we're going to put a title, which is Jared. It's usually going to be the same title. Oh, come on, where's my apostrophe? Oh, it's there. It's just hard to see. Jeremy's marble experiment. Okay. I don't know why. I think it's because my font is too big. Bring that down because it's bugging me that you can't see my apostrophe. Miss Brandon likes to be correct, y'all. Well, it's still not showing up. Okay. You trust me that I put an apostrophe, right? I don't know why it's not showing up above there. All right, so right here, let's do the colors on this side. Blue, green, oops, not here, and red. Why isn't the here showing up? Okay, and so what we're going to do here is it says to use circles. Sometimes you get to make up your key. Sometimes it tells you what the key is. And so what we want to do is record the key at the bottom right here. That's usually where they put the key on a pictograph. So the key is a circle, equals to, I'm just going to put M because writing is hard on my laptop, 2 marbles, okay? Each circle equals 2 marbles, so let's do it. Come on. There we go. All right. How many chose blue? we're going to count by twos because that's what the key told us. So 2, 4, chose 2, 11 for green. Let's start counting by twos. Let's see what we have to do. 4, 6, 8, 10. Can I put a whole dot here for, oh no, that would give us 12, wouldn't it? So you know what I have to do? I have to erase half of it. Oh, is it not going to let me? Rude. It's not erasing it. Oh, there we go. Okay. So do you see how we had to erase? Now it's erasing. Oh my word, y'all. Sometimes the laptop is mean to me. It's just delaying it for some reason. Okay. Pen is what I've chosen. And then we're going to get rid of half of it. And you know what I'm going to do? How I'm going to do it? I'm going to do this because the eraser is being weird. So I'm just going to use the white as an eraser. Okay. So do you see how we did that? We did, just pretend like I didn't accidentally erase the key there. We did 1, 2, 3, 4, 5.5 dots to get to green because a half of one, if one dot equals 2 marbles, then a half of one is just going to equal 1, right? So for the red, 2, 4, 6, 8. All right, moving on. Okay, here they just want to know on this one what's missing from this pictograph. Okay, what do we need to be able to analyze this data? We have a title, we have the categories, we have the pictures, but do we know what each diamond stands for? No, there's no key, okay? We have to have the key to be able to analyze this data because each diamond shape might mean 1, but it might mean 5, and that's totally different, okay? Now they're giving us a clue. If Karen made, here's Karen, this is her jewelry. If she made 9 bracelets, then what does 1 diamond stand for? So let's find bracelets. If she made 9, I'm thinking it's 3s. 3, 6, 9, okay? So now we know that each diamond equals 3 pieces of jewelry, okay? We were able to tell that from our clue down here. So now how do we know, how many necklaces did Karen make? 3, 6, 9, 12, 15. See that? It's a little problem solving here. All right, which frequency table matches the pictograph? Let's look at the key first. Each tree equals 6 national park areas, okay? So I can already tell you that this one is wrong because look, it has each tree only counting for 1. We have 1 for Michigan, 1 for Minnesota, so that's not it. It's got to be B because that matches the key. You've got to pay attention to that key. Don't let it trick you. Okay, the school principal surveyed students to determine their favorite flavor of ice cream. All right, 80 different students voted for the chocolate ice cream. Whew, that's a lot. So I'm going to write that number up here. 80 voted for chocolate. What does it say? 30 voted for strawberry. And 50 voted for vanilla. So based on that information, how many in our pictograph, how many does each cone stand for? If we have 80 here and 1, 2, 3, 4, 5, 6, 7, 8, 8 times what is 80? 10, right? So we're counting by 10s here. And let's check our answer with the others. 10, 20, 30, that matches. 10, 20, 30, 40, 50, that matches. So sometimes they want you, the math people want you to go backwards and figure out what the key is and see how your problem solving skills are. Okay? All right, we've got a pictograph. Let's see. Nicholas realized he forgot to represent the number of students with 3 or fewer. Okay? If there are 54 students in 3rd grade, this is a lot to do. I'm not sure I can do it in the 30 seconds I have. Okay, the circle is 4 students. So 4, 8, 12, 16, and look, they've got a quarter of it, so that's going to be just 1, 17. Okay, 4, 8, 12, 16 plus 3 is 19. So we've got 17, 19, and then 8, 9, oh, 8, and then we got 10. Oh my goodness, I'm not going to do it in time. But what you would do is you'd add all these together. subtract it from 54, and that's how many should go